try to move our attention to organic reaction. And the first type of reactions that we're going to be dealing with are addition reaction. And then in the next lesson, we'll talk about elimination. And then the other lesson after that, we'll talk about substitution, right? So let us get into it. So how would we define addition reaction? Addition reactions in general. So we would say, if you ask this, we would say that addition reactions are reactions where atoms are added to an organic molecule. So we adding atoms, hence addition. And then normally you add these atoms to either a molecule that has a double bond or a triple bond, right? So it is either to an alkene or an alkyne. But our focus is mainly going to be on alkenes, right? And then when you add these molecules, when you add these atoms to this molecule, that double bond will break open, and then we will form new, and the new atoms will be added to the carbon atoms on either side of the double bond or triple bond. No, that's a lot of English, but now let us actually try to see what is it that I'm saying. So before we do that, I want you to notice that we can either to add hydrogen, which is H2, or add a halogen, which is, what is it, Cl2, or add a hydrogen halide, maybe Cl, or it can be HF, or it can be HI. So these are all your halides. Or we can add, what is it, water. So there are four things we can add. We can either add hydrogen, a halogen. So halogens can also be F2, I2. What's the other one that I keep forgetting? Or Br2. And here we can also add HBr. Or we can add a hydrogen halide. So it's a hydrogen bonded to a halogen. So it can be either HCl, HF, HI, or HBr. Or lastly, water. So those are the four types of addition reactions that we're going to be focusing on this lesson. So let's start. Let us say the first type of addition reaction is when we add hydrogen, H2. And when we add hydrogen, we call that type of addition reaction, we say it is hydrogenation, because we're adding hydrogen. So hydrogenation. So we can take an example. In this case, normally you have your alkene or alkyne. In this case, we're only going to refer to an alkene. And you add your hydrogen, and normally you will get an alkane. So let us take a simple alkene. Let us say we had a propene. So propene means we have 3 carbons. H. Nope, I'm lying. There's no bond there. And we have an H. And then we add hydrogen. So it's 2 H's, right? And then we're supposed to get an alkene, right? So what's going to happen? This double bond is going to break. And then when it breaks, so the one hydrogen will come to this carbon, and the other hydrogen will come to this carbon. And this one will break, it will form a single bond. So we'll have C. We have that new hydrogen. I wish I had a different pen. Hydrogen, another new hydrogen there, and then you have your old hydrogens. So as you can see, we formed propane, which is an alkene. Quite straightforward, no? It's not that complicated. So the other important thing that they would normally ask you is to define some reaction conditions. So what do we need for this reaction to proceed? So we have to make sure that the alkene is dissolved in a nonpolar solvent. So you need a nonpolar solvent. Additionally, you also need a catalyst, and that catalyst can either be, let me think, can be platinum, nickel, or palladium, right? So it needs to be present, that type catalyst, for this reaction to proceed. Okay, now let us move on to a second type of addition reaction. And I want you to note something with addition reaction. So normally with addition reaction, you start from either a triple bond or a double bond. And we know that those triple bond or double bond molecules with those triple bonds or double bond, we say they are unsaturated. So you move from an unsaturated, and then when you only have single bonds, we say that bond is saturated, or that molecule is saturated, right? So what are you noticing? You're actually moving from an unsaturated molecule to a saturated molecule. This is unique to addition reaction. Cool. Let us now type of reaction that we can consider is what we call what is it? Halogenation. So it's when we add halogens. So we can either add Cl2, Br2, I2, or F2. So when we add those halogens, that reaction we refer to it as halogenation. We're still adding it to a unsaturated double bond. In this case, we're taking an alkene. We're adding that either Cl2, it can also be Br2, or any of this. And then what we're getting is that we will get a haloalkene alkane at the end. Okay, so let us show you how this would normally proceed. So let us say we added chlorine or chloride into, so we have your chloride, and then you adding it to propene still. Who I am today. Okay, so what kind of chain do you expect? So what would happen is, before, this double bond will break, and then this Cl2, so one chlorine will go here and the other chlorine will go there. So at the end you will be left with something like this, where you have your chlorine there, and then you have your H maybe, and then you have your chlorine. That quite straightforward, these two reactions, right? And then this is your haloalkane that you formed. So try to see if you can actually give an IUPAC name for this haloalkane, right? Okay, so now let us move on to another reaction, which is called hydrohalogenation. Hydrohalogenation. So this is when we add either HCl, HBr. So you have a halogen bonded to hydrogen, or Hi or HF, right? And then you adding this to an alkene. And then what you get will also be a haloalkane, right? So let us take an example. So let us say we were adding, I feel like I need more space, but it's fine. So let us say we're adding HCl, and we're adding it to still propene. So 3 carbons, there's a double bond there, there's H, 1 2 3 4. Is that right? This doesn't want to, no, this is not there. I feel like, let me just start this on a different page, because now it looks very cramped, right? So our discussion is still on hydrohalogenation. Hydrohalogenation. And we said that we were adding HCl to propene, right? And then what we will get is actually a haloalkane. But there's an important consideration here that we have to make. So in this type of reaction, so you're realizing that you have, so the double bond will break, and then hydrogen will be added to the one carbon, and then chlorine will be added to the other carbon. So but then which carbon gets hydrogen and which carbon gets chlorine. So in this regard, what is going to form, we can either form a major product or a minor product. And a major product is going to be formed when we make use of what we call Markovnikov's rule. I hope I'm pronouncing that right. And Markovnikov's rule basically says that the H atom will bond to the carbon atom which has a greater number of H atoms. So this H atom here will bond to the carbon which has a greater number of H atoms. So our discussion is which between these two carbons, which carbon has the greater number of H atoms. So you see this one has 1 and this one has 2. So according to Markovnikov's rule, this hydrogen will be bonded to a carbon with a greater number of hydrogen atoms. So meaning this carbon will actually come here and the chlorine will come there to form a major product. So we'll have a case of C, C, C. The new carbon will come here. Just want to show you where the carbon went. You don't need to include this thing when you're writing. And then the chlorine atom will come there, and then you have your molecule such as that. So this is when you form your major product. For your minor product, it will just be the opposite. Your hydrogen will come to a carbon atom with the least number of hydrogen atoms, and your chlorine will go to the carbon atom with the highest number of hydrogen atoms, meaning this will be your thingy. So your chlorine will come here and your hydrogen will come here. So I'm hoping that is clear in terms of how do we form major and minor products. So for a major product, the hydrogen comes to the carbon, which has the greater number of H atoms. You see this carbon has 2 hydrogens and this carbon has 1 hydrogen. So this hydrogen will come there, then the chlorine will just go there, right? And then what are some of the important things to note about this is that for this reaction, it's quite important that you don't have water present. So no water must be present for this no water present for this entire reaction to proceed. So now let us do the last addition reaction that we need to know. The last one is hydration, where we add water, right? So let's start. We have water, and then you add it to our alkene. In this case, it's still propene. There we are. And as was the case with halogenation, we still have to form either a major product or a minor product. We're still using the same rule, Markovnikov's rule, about minor product, right? And then, so meaning here, so you have H2. So it's OH, the hydrogen will go to the carbon with the greater number of hydrogen atoms. So hydrogen will come here, because if you compare these two carbon atoms that have a double bond between them, the one that has a greater number of hydrogen atoms is this one, meaning the hydrogen will go there. So if you take the hydrogen, we are left with OH, and then the OH obviously will now come here to form the major product, right? So meaning we're going to have a situation like this. The H will go here, and then the OH will come here, forming an alcohol, if you realize that. I'm getting a bit tired. It's been a long day. Okay. And then if you form a minor product, it will just be the reverse of this. The hydrogen will come here, and then the OH will come to this carbon with the greater number of hydrogen atoms. So sometimes you are asked for major product or a minor product. So just know the difference between those two. So the OH will come here, and then the hydrogen will come here after breaking this double bond. And yeah, so there we are. So a few important things is that, so you have water, you add it to an alkene, and at the end you get an alcohol, right? Quite interesting if you think about it. So, like I mentioned, a few important things are some reaction conditions. For this reaction to proceed, you need a very strong dilute acid. It can either be strong dilute acid. The most common will be your hydro H2SO4, sulfuric acid, right? Or and then you also need heat in the form of steam. So you also need heat in the form of steam, meaning that's H2O, right? Reactant. And yeah, this actually now brings us to the end of this lesson. I hope it cleared any confusion you might have about addition reaction. The next lesson is going to be on elimination, which is just the opposite of this one. Yeah, see you on the next lesson.